Hi everyone, welcome back. Let's see the need, functions and the goals of memory management. Guys, generally when we have come across the concept of memory hierarchy, we observe many kind of memories, or I can say different kind of memories we have observed. Something like registers, cache, main memory, secondary storage devices, like that we have seen, right? Among all the various kind of memory devices, if you take CPU can able to directly interact with these memories, which I can say that CPU performance is directly proportional to how the main memory is working, right? Yes, for example, if I say there are 10 processes are executing in main memory, which is less efficient or less CPU utilization compared to 100 processes which are executing in main memory. Is it true? Yes. Means what? If I am saying that 100 processes are executing the main memory, which means 100 tasks are parallel executing. Here 10 tasks are parallel executing. Then which one will be the better one? Obviously the main memory, where it contains 100 processes, right? Because at a stage we are going to complete 100 tasks. So this is the better one. So based on this example, I can say that if a main memory having more number of processes, or if I say if I load more processes in main memory, can I increase the CPU utilization? Yes, definitely you can increase the CPU utilization, right? If you want, I can give a small example. For example, let's say there will be a main memory whose size is assuming it as 2 MB, and generally all the process sizes are 2 MB assume. If I am having this kind of situation, how many processes can fit here? Only one process. Am I right? Because in the 2 MB memory space, if I am going to allocate 2 MB process size, then what will value? You will get the one process will be allocated in the main memory. And so for example, I am assuming that there will be the process spending P time for IO operation. So for example, if I say 80% of its time is spending for IO operation, then what will be the CPU utilization? Obviously you can say directly as 20%, which means that if I am going to have a CPU, here process is allocated, out of the allocation I am the only one process. If I went for 80% of the time for CPU idle, what is the CPU utilization? Definitely that will be the 20%, right? So for example, look at the another variant. If I am writing as means main memory, size is 4 MB, process size I am saying it as PS, which is of same size, guys, and P time is spending for 80% of IO operation. Then what will be the CPU utilization? How many processes will fit in the CPU now? You can fit 2 processes, 4 MB by 2 MB, 2 processes fit in the CPU. Then what will be the CPU utilization, which will be based on the probability formulas. We can say that 1 minus p square, which is equal to 1 minus 80 by 100 whole square, which is approximately equal to around 36%, guys. Try to observe, if I am going to have only one process, how much is CPU utilization? 20%. If I am having two process, how much is the CPU utilization? 36%. For example, with the help of same factors, the main memory size I have increased it to 8 MB. Then how many processors are supposed to fit? 4 processors obviously. Then the CPU utilization will be 1 minus p power 4, which is approximately equal to 60%. Guys, if I increase more size, main memory will be 16 MB, and how many processors I can able to fit? 16 MB by 2 MB, which is 8 processes. Then the CPU utilization will be 1 minus p power 8, which is equal to almost 83%. Guys, try to observe, is the CPU utilization is increasing as soon as you are increasing the main memory size, right? Which means if you are able to increase the main memory size, definitely CPU utilization will be increased. I can say it as main memory size is directly proportional to CPU utilization effect, right? So when you are going to have like this, can I make the main memory size as infinity? You might get question, right? If I give the main memory size as infinity, definitely I can achieve the CPU utilization always 100%. Is it possible? Generally CPU utilization 100% is possible, but main memory size infinity makes it is impossible, because you know all these things, registers, cache, main memory, as you are trying to get towards the top words, the cost of accessing will be too high, right? So with respect to the feasibility of the cost, we cannot able to make the infinite amount of memory, right? But you have to think in such a way that if we have a main memory, you have to assume that this is our infinite memory, and you have to place as many processes as possible. Place as many processes as possible, so that definitely CPU utilization will be improved, right? How much, right? Is it feasible for us? We can able to place that much, right? We have to make it effective utilization, right? Guys, generally, if I am having one process, if I am having only one process which is under the computation, I can directly load, right? Load. That is the easiest one. But if I am having more than one process or under the computation to load into the memory, then definitely there will be some kind of computation. So what you have to do now? You have to go with the certain kind of memory management techniques, right? Hope you understood why we are going for the memory management technique, right? In order to load one of the process among all the process, you have to go with the memory management technique, and also to make it more number of process as possible as into the main memory, we are going with the memory management technique. These are the two things, right? So what the memory manager will do here generally, which I can call it as functionalities of memory manager, right? One will be is responsible for to loading the process. I can say it as allocation of memory to processes. This is one of the functionality of the memory manager. And the another one will be, once it completes its task, what you have to do? You have to deallocate the memory. Deallocation of memory from the processes. This is one more functionality. And the most important one is protection, guys. Protection. Guys, generally what is the meaning of a protection means? In simple words, if I say there is a main memory. Initially main memory contains what? Operating system, and the remaining things are going to be filled with the various kind of process according to the memory manager. So for example, process P1, P2 are loaded into the various locations. If I am able to say, right, process P1 at any cost should not access with the data of process P2. Similarly, process P2 should not access the data of process P1. Means the operating system has to protect our process data, our program data from the other process. We can call it as protection. Protection is one of the functionality of the memory manager, and which has to work with how to free up the space. That means it has to manage the free space management. These are the functionalities of the memory manager. And coming to the goals, what are their aims? Means, as per my explanation, you have understood. One thing will be efficient utilization of main memory. Efficient utilization of the main memory, right? So that I can able to place more number of process. Means, in other words, if I say I have to avoid wastage of memory, right? This is the one of the goal. And another goal will be when you are going to have larger process, guys, larger process which has to be executed. Larger process has to be executed in smaller memory areas. This is one of the goal. The reason is we are having less memory space only. In this less memory space, you have to load more number of process. That's the reason when you have larger process, right? Means we have to manage execution of larger process that has to be executed in the smaller memory areas. This is another goal. So I can call this the two goals mainly for the memory manager, right? Yes. Hope you understood this video. In the next video, we'll see what are the various kind of memory management techniques and its explanation. Hope you understood this video clearly, guys. Thank you.